Okay, you can hear me, right, Sumukh? Let's get started.
Yep.
Yeah. Good morning, good evening, good afternoon. Hello, everyone. Welcome to another episode of the YugabyteDB Friday Tech Talks. This is Kannan Muthukkaruppan. I'm one of the co-founders at Yugabyte. And it's my pleasure to welcome Sumukh Phalgaonkar. He's joining us from India. I'd love for him to introduce himself and then go into today's topic. I believe this is like the 153rd episode of our YFTT series. So welcome all to the this talk. Over to you, Sumukh.
Yeah. Thanks, Kannan. Yeah. I'm Sumukh Phalgaonkar. I've been working at Yugabyte for the last 2.5 years as a software engineer. And I'm part of the database team based in India. And today I'm going to speak about the latest enhancements in logical replication. So yeah, let's get started. The agenda for today's YFTT is going to be following. I'll give a very brief overview about what logical replication is in YugabyteDB. Then we will talk about the observability enhancements that have come in with logical replication. And then we will see the latest advanced enhancements in while consistently streaming changes for new tables as well as for publication changes. So yeah, let's get started. So let's get started with the logical replication overview. This is going to be a very short overview. If you're interested in a deep dive, we have already done a YFTT for that, and you can find it on YouTube. So yeah, let's get started. So as you might be already aware, YugabyteDB offers two different models of change data capture, that is CDC. The first model is gRPC, and it is a Yugabyte specific native replication protocol, and it uses the internal master and T server ports for replication. In order to create and manage YugabyteDB gRPC streams, you need some YugabyteDB specific binaries called YBadmin. And there's only one client which you can work with when you're using the gRPC model, that is our own custom Debezium connector. On the other hand, the second offering for CDC is logical replication, which is based on Postgres' logical streaming protocol. Here we make use of the Postgres port, that is 5433. Creation and management of streams is easy using Postgres' syntax and semantics for replication slots and publications. And the good part is any client which understands Postgres' wire protocol can be used with logical replication. We have our own Debezium connector, which is one such implementation, but there's no bar as to what client you can use with logical replication. In
And
this slide,
yeah, maybe
yeah,
the just to make one point on the previous slide, fundamentally this extends our work and approach on bridging the Postgres compatibility in Yugabyte. So not just the SQL syntax or the SQL features, but in how products around interact with the database. Like you want to capture changes and connect microservices from Yugabyte to other microservices. We just want to follow Postgres's standard capabilities in enabling those. So this is basically with that same principle in mind. Thank you, Sumukh.
yep. Yes. So in this slide, basically explains a very top level overview of how logical replication works. On the left, you see a user performing some DML operations, which are getting stored in your Yugabyte DB. Any client, may it be a Debezium connector or any other PG-wire reading capable client, will connect to the 5433 port, start a wall sender process, and consume those changes. Now, from the client, you can either send the changes to Kafka or some sync database, a data lake, downstream applications, some cache. The possibilities are really endless. As Kannan just pointed out, there are certain benefits of using the logical replication over the gRPC model. The prime benefits are like you get all the benefits of Postgres' replication client persona, that is authorization, authentication, SSL modes, connection load balancing, everything is inherited. Also, there's no need to expose these internal ports for master and T server. And the best part, you get the benefits of plug and play into Postgres' ecosystem for logical replication. So that's where PG parity comes in. Now, this is a brief overview of logical replication. Let us say you have already set up a logical replication stream using YugabyteDB. How do you monitor the health of such streams? And to do this, there are two capabilities that YugabyteDB provides. The first one is server-side metrics, which will be displayed in dashboards on your YugabyteDB YBA UI. The second way is by querying the cumulative statistics views. The statistics views are inherited from Postgres, and because of the YugabyteDB's Postgres parity, we also support these views. Let's first take a look at the metrics which are available. So on the dashboard side, we have four metrics available. The first two metrics tell us about the events which are being shipped by CDC. So there are two metrics here, the change event count and traffic sent. Change event count basically states the absolute number of events that are being sent by CDC, whereas the traffic sent metric is telling you the size of each message that is being sent. Now, whenever CDC is set up, we suspend the garbage collection of certain resources like wall files, intents, etc. So that in the case where your CDC stream lags, it will be able to correctly stream the change records. As and when your CDC starts streaming, the client will send acknowledgement for the receipt of certain records. As soon as you receive the acknowledgement, you proceed with the garbage collection of wall files, intents, and other resources. The
And
third
just
metric.
for clarity, the wall file acronym WAL is basically a write-ahead log or a transaction log. And essentially, change data capture is implemented by subscribing to changes in the transaction logs. And that's what Sumukh is implying, that if for whatever reason the CDC stream is lagging, like if the other side, the microservice is down and you need to catch up, you may be lagging by 10 minutes and so on. So you need to maintain keep a retention for the wall to a longer period to enable picking up from where you left off.
Yeah.
Yeah.
Right, Kannan. So this metric exactly helps you to find out how far behind you are lagging. So the flush lag metric is simply a timestamp difference between the latest acknowledgement that you have received versus the latest record that you have written. So if you have a lag of 1 hour, it basically means that your change data capture is right now shipping records which were committed an hour ago. Let us say you have created a replication slot, and because of that, we have put some resources retention barriers. If there's no client which is polling from that replication slot, we would end up with unnecessarily holding these resources. Hence, each replication slot comes up with its own expiry time. So what this means is, if for an expiry time interval, no client is consuming that slot, then we declare that the slot is expired, and hence there's no need to retain these resources. The garbage collection of log files, wall files, intents, etc. can proceed. And this metric basically exactly points how much time is left for a stream to be declared as expired. The default value is 8 hours, but you can configure it up to 24 hours. So this was a brief overview of the metrics that are available. Let us jump into a quick demo to see how you can access these metrics. So for this demo, I'm using a 3-node YugabyteDB RF3 cluster, and I've created a single table called employee on it. It's a very simple table with just 3 columns, and I've set up a simple workload which is inserting about 50 rows every second. As you can see from the total YSQL ops, we are getting about 50 ops every second. I've also set up a CDC pipeline on this universe where I'm pulling the changes from this employee table and sending them to Kafka. To monitor the CDC operations, you need to click on the CDC tab right here. Once you click here, you'll get a list of all the replication slots that exist on this universe. So as you can see right now, I have only a single replication slot named YB replication slot. The status of the slot is active, and it was created on Yugabyte database, which is a default database, and it is lagging by about 19 seconds. To view further metrics, you need to click on it. So as soon as you click, you'll see a bunch of dashboards popping around your screen. Let us take a look at each panel one by one. Let's take a look at the central panels first. So as you can see, the central panels have something called as
So
replication slot.
by the way, one
Yeah.
question was was the information in seconds or milliseconds? I think you mentioned some time.
Right, right. The metric inherently is calculated in microseconds, but on the dashboards, it is converted for the replication slot. We are displaying it in milliseconds. This is a count metric, and this is an MB. And the replication slot, we are displaying it in minutes.
Got it. Yeah, for the lag metric, and I know maybe milliseconds is too fine grained. I think seconds might be something we should consider. Seconds in the granularity for the display purposes. Yeah.
Right, Kannan. So if you look at the top of the screen, there is another place where we're displaying the lag metric.
Hmm.
There it is converted based on the value. If the value is too large, it can even be converted into hours.
Yeah, yeah,
So
got it.
this,
You,
yeah,
you make it a human readable format at that point. Yeah. Okay.
right, yeah. So yeah, moving forward, so as you can see, the central two panels are basically telling you how many messages or what is the byte size that is being shipped by CDC.
Hmm.
And you will notice that these are not absolute numbers, but these are actually the rate of those change events. So looking at the central metric, you'll see that we are shipping about 50-55 ops per second. And this corroborates with our write rate, which is also inserting about 50 rows per second. And since our schema is a simple one, I'm getting about 0.015 MB per second. Now, this is about the change event metrics. What about the lag? So as you can see here, lag is basically a timestamp difference, and it is oscillating somewhere between 15 to 45 seconds. Now, why is this the case? This is because my client is set up in such a way that it sends an acknowledgement every 30 to 45 seconds. So between two acknowledgements, the lag metric increases, and as soon as it receives an acknowledgement, it falls back down. So this is the normal behavior that you can expect to see. It will oscillate within a very small range. Next metric that we have is the slot expiry time. This metric simply tells you how much time is left for a slot to be considered expired. So let us say for whatever reason your client goes down, there is an out of memory incident or anything, and you can see here that right now it is 8 hours. As soon as your client goes down, this will start dropping. So you will see that from 8 hours, it is going down to 7 hours, 30 minutes, 6 hours, and so on. So this basically tells you that you have 6 hours left for you to figure out what went wrong with your client, get it back up running again, so that you can start or you can resume streaming from where you left off.
Hmm.
If for whatever reason this particular metric drops down to zero, the slot will be considered as expired. This line will show a value zero, and we will free up all the resources that we are retaining. And this replication slot status over here, it will show expired, and this slot is no longer usable. Then you can drop the slot and create a new one if you want to proceed. Now let's see what happens if I delete the connector. So to do so I need to be on the right machine first, and then I just need to execute this curl command where I delete the connector. So here I have deleted the connector now. What this means is that now there is no client pulling the changes from the YugabyteDB. So as a result, we'll see that this messages emitted and the messages emitted size will start dropping down to zero since there's no polling and there's no records being shipped. Also, the next thing you'll notice is the replication slot expiry time will now start dropping from full 8 hours to whatever time it is taking. And since the workload is active, that is, we're still inserting, but CDC is not consuming, the lag will also shoot up. So let us see what happens by refreshing. So as you can see here, the change event count metrics have started dropping and your expiry time has dropped down. So it was 8 hours earlier and now it is 2 minutes, 7 hours, 38 minutes, somewhere it has dropped down. What this means is the timer has started ticking and you have this much time to figure out what went wrong, get your client up again and resume your streaming. You can see here that lag has also started rising up. If I leave the client off for a while, the lag will also accumulate to a good value. Now, let's see what happens when we redeploy the client. Yep, the client has been redeployed. Now the expectation is the replication slot messages emitted should shoot up. And by shooting up, I mean it should go beyond the 50 ops per second limit because now we have some lag that we have accumulated and we need to catch up. Similarly, eventually the lag metric will come down. And the slot expiry time, since the client is back up again, should go back up and it should come back to full 8 hours. And as you can see, replication slot messages emitted is now close to 6,000 ops per second. This is because we are now trying to catch up on the lag that we have accumulated. And we have about 1 minute, 38 seconds of lag. That is, we're streaming data which was committed a minute ago. Your expiry time is now back to full 8 hours, which means whatever damage was done when your client was down to your expiry time has now been restored. Your client is healthy and polling continuously, and your CDC stream is healthy right now. So, this is all about the metrics dashboard. Now, these metrics are also exported via the Prometheus endpoints, and you can use tools like Grafana and link it with your Prometheus, and you can create your own custom dashboards with it. You can also set up alerts. A good example of alert will be on the expiry time metric. Whenever your expiry time metric drops below a certain value, you can send alerts as to check what's wrong with the client so that you are able to figure out and you're able to fix the issue and get the streaming resumed again within this much time. Another good alert will be on the CDC write rate or CDC event sent rate and comparison with it with the write rate. So if your CDC streaming rate is significantly below the YSQL ops, then you will see an ever increasing lag. And such a stream will not be considered as a healthy CDC stream. In such cases, it could be a transitive error, or it could be something which requires remodeling of your how your CDC deployment works. That is all about the metrics dashboards.
One
Now,
question, Sumukh. The metrics that you were showing on the previous page, say you have, suppose you have a 6 node cluster.
hmm,
Uh, is that view aggregating all the data across those 6 nodes? And could you speak a little bit to that?
right. So the view which you get on the YPA UI is aggregating across all the nodes. But if you want node specific data, you can also get that by going to the Prometheus endpoint and running specific queries. Like the queries are already aggregating it. You just
Mhm.
need to remove the aggregation functions and get the per node value of the metric as well.
Fair enough. Thank you.
Yeah. Yeah, let's move forward. The second way you can monitor your replication slot streams is how you do it in Postgres. That is by querying one of these catalog tables or statistics views. So we have 5 such tables or views which you can use to look at the health of your replication slots. So one of them is PG publication table, PG publication, replication slot, stat replication, and stat replication slots. Without wasting any time, just let's just jump into the demo of these views.
Sorry if I missed it. Did you say that these are standard views in vanilla Postgres also?
Yeah, that's correct, Kannan. Yeah.
Yeah.
So in Postgres, these views are the only way you can monitor like
And
the
we have kind of done, basically implemented the same views to the same spec, but using our underlying implementation of, yeah.
that's correct. Yes.
Okay.
Yep. So let's get started on this. The first view that we will be looking at is PG publications. So let me run a select star query on PG publications and see what we get. So as you can see here, this view basically lists down all the publications that you have in your database. So you get the OIDs of the publications, their names, and the OID of the owner who created them, and a bunch of other information. So right now I have 2 publications in my database. First one is called pub, and the second one is called pub all tables. Now you'll see the fourth column is pub all tables. What this indicates is whether the publication that you are referring to in the next row, does it include all the tables in the database or does it include a subset of those tables? So as you can see, the first one is only including a subset of the tables, whereas the second one has all the tables in the DB. Along with it, you get a bunch of other information like what all operations will be streamed for the tables in this publication, and those are indicated by the other columns: pub insert, pub update, pub delete, etc.
And what is the
Now,
what is the significance of pub all tables column being set to true? Is
right.
the idea that if a new table pops up in that database, you automatically want to add it to the CDC streaming mechanism?
Right, that's absolutely correct. So when you're creating a publication with all tables, anytime you create a new table, it will automatically get added to this all tables publication. Whereas if you want a finer control as to what all tables you want to stream, Then you go with the specific tables, and in such cases, you need to manually alter the publication to add or drop tables.
Yeah.
So the next view that we'll look at is PG publication tables. So as you can see here, this view basically lists down all the tables that are part of the publication. So right now, since I have only a single table in my database employee, both these publications contain this particular table. Let us see what happens if I create a new table. So I'm creating a simple table student and querying this view again. And as you can see, the publication pub all tables now has both the table, the newly created one, but the first publication pub does not include the table student. Now, in order to add it, I just do an alter publication and add the table student to the publication pub. And just like that, now student is also part of the publication pub. Now let's go further and look at our next view, which is PG replication slots. As you can see here, it has a bunch of fields in this. Some of them, like slot name, are pretty obvious. You also get to know which plugin you're using for the slot. You'll get to know which database the slot is pulling on. You'll get to know whether it is active. Now, active here means whether the slot was used within the last minute or not. In addition to that, you get something called as confirm flush LSN and restart LSN. Now, confirm flush LSN is the last LSN which the client has acknowledged, whereas restart LSN means the LSN from which we will start streaming again in case of a wall center restart. The restart LSN will always be less than or equal to confirm flush LSN because upon a restart, we send the whole transaction again. So in case you have acknowledged in the middle of transaction, we will in the event of restart, we'll start streaming from the start of transaction. Also, you'll see a field here called wall status. Now, this wall status field basically tells you whether your slot is expired or not. So it can have two values. Either it can have reserved or it can have lost. If your wall status is reserved, it means that your slot is good to go. It's perfectly retaining all the resources. If it is showing lost, it means that the slot has expired. You can no longer use the slot. You can drop the slot and create a new one. In addition to the Postgres specific fields, we also have some Yugabyte specific fields here. For example, YB stream ID. So internally, every replication slot is a CDC stream and each stream has an ID. This stream ID comes mighty helpful when debugging issues. Also, there's something called as restart time. Restart time is basically the last commit time which was acknowledged. So anytime your wall center restarts, the first DML which you will send will have a commit time greater than or equal to restart time. Now, let us run a sample query on the PG replication slots and see what we get. So right now I have a single replication slot. It is using YB output plugin. The restart LSN is just one shy of the confirm flush LSN. The wall status is reserved, meaning we are perfectly fine with the slot. This is the stream ID, and this was the last commit time that I got an acknowledgement for. Now, let us move to the next view, which is PG stat replication.
Can I ask one more question?
Sure, Kannan.
Like, just to get the mental model for our audience, like in terms of like, if suppose I want to suppose I have two clients. One is trying to write the data changes to say Redis, and another is trying to write to Kafka. Is that when I would create two publications? And sort of like, what is the connection between why do I have multiple publications and then why do I have multiple slots? If you could just walk people through that.
Definitely, yeah. So let us say you have two clients and let's say you have three tables and two clients. One of the client is sending the data to Redis and the other one is sending to Kafka. In this case, you will need two replication slots. And you can use the same publication provided both these clients are interested in the same set of tables. If your first client is interested in table 1 and table 2 and the second one is interested in table 2 and table 3, that is the sets are not identical, then you will need separate publications as well. So there is no one-to-one mapping between publication and slots, but yeah, it's use case dependent.
Got it. If the group of tables that you're interested in consuming with the same kind of transactional consistency across those group of tables, then they can share the same. Uh,
Publication.
got it. Same public. Got it. Yeah, I think somebody said the font sizes on the CLI is a little fuzzy. Yeah, I think it's true on smaller screens. It's a little fuzzier. I don't know if there's anything we can do to fix it live, but we'll try to keep that in input in mind for future.
Yep. All right. Yeah, let's move forward. So, yeah, the pgstat replication view is a local view. And what I mean by this is, let's say you have two nodes, node 1 and node 2, and wall sender 1 is running on node 1, wall sender 2 is running on node 2, that is two different clients. If you run a query against pgstat replication on node 1, it will give you information about only the wall senders active on node 1, whereas if you run the query on node 2, it will give you information about all the wall senders running on node 2. That is, running this query on different nodes can give you different outputs. So that's one thing to keep in mind when querying these pgstat replication and pgstat replication slots view. So as you can see here, it has a bunch of information like PID, which is the process ID of the wall sender. Username and user sys ID is the user identification, whoever started the wall sender process. The client address, application name, host name basically tells you who started the wall sender process. The flush LSN and write LSN, as explained above, relates to your acknowledgements. And we have three lag fields here: write lag, flush lag, and replay lag. In Postgres world, these three things can mean three different things. But for us, there's only one type of lag which is applicable, and it is the same one which we have already shown in the metrics dashboard, the timestamp difference between the latest acknowledged record and the latest record which has been committed. So for us, all these three lag will show the same value. Let us run a sample query here. And as you can see here, I have about 47 minutes of lag. And this is when my backend started. This is the address of the client who started the wall sender. Debezium streaming means I use the Debezium connector to start the wall sender. And this is the PID and username who started the wall sender. The next view and the last view for us today is pgstat replication slots. Again, this view is also a local view. And as you can see here, it has the slot name and something about spilled transactions. So wall sender basically gets the change records and puts them in a reorder buffer. It does this to get the full transaction in a single flow and then send the whole transaction. But sometimes if you have large transactions, the reorder buffer will have to incur extra memory overhead. To prevent this, if a transaction is greater than a certain size, then we spill the transaction onto disk. These three fields here basically tell you about how many such transactions, what are the bytes that we have spilled onto disk. The next three fields, stream transaction, stream count, and stream bytes, basically tell us how many in-progress transactions we have shipped in Postgres world. But with Yugabyte CDC, we only stream committed changes, hence these are not applicable to us. The total transactions and total bytes basically tell you the total number of transactions and total bytes that we have streamed in this wall sender's lifetime. So let's run a sample query on this view as well. And here we see that, yeah, spill transaction, spill count, spill bytes is 0 because all my transactions are small. Stream transaction, stream count, and stream bytes will always be 0. We have shipped about 1200 transactions and these many bytes in the lifespan of this wall sender. So that's it about the cumulative statistics and views. Any questions about
Yeah,
that?
one question. If you could just stay on the previous screen a little, like the
Sure.
previous view a little bit,
Yeah.
or that was in the part of the demo. Never
Yeah.
mind. So, question is like some of these views, like today, a view like PG stat statements that Yugabyte has is per node, right? Because it's getting served from in-memory state on that node. But what about these? Are these getting served from like the global table, like CDC state? Can I connect to any node and get the overall information about all the slots active on the distributed, Yugabyte database?
Right. Let me answer that question. Let me go to one slide back. Yeah. So out of these views, the first three are global views. That is, you can connect to any node and query them. You'll always get the same response to your query.
Okay.
The stat views are node specific.
Got it. Just like PG stat statements, this is also node
Exactly.
specific.
Yep. Yep.
And just to share with the audience, we have on our roadmap uh, extending all the stat views to kind of a global version of these views, like Oracle. I think, for example, for Oracle Rack, they had the G dollar version of those views that uh, fanned out to all the nodes to collect that data. We also have that on the roadmap. But thanks for clarifying that the last two views are node specific.
Yep. All right. Let's move further. And now let me talk about the latest enhancements that we have done while streaming, consistently streaming, and there are changes to the publications being made concurrently. So let me first clarify what the Postgres semantics are. The contents of a publication can change in two cases. Firstly, when you create a new table, or secondly, as we have just seen, by running an alter publication command. If your stream is lagging, which is most often the case, in case of a creation of new table, we should stream the contents of this newly created tables only after the stream has shipped all the records which were committed before the table creation. And for alter publication, even if the table existed before, we should only ship those records which are committed after the execution of alter publication. To enforce the semantics, it is easier in Postgres because they have a single wall file that is a single write-ahead log, and you get to know when the publication was altered, and from the immediate next line, you can switch to the new table list. However, this is not so simple in Yugabyte owing to its distributed nature. So the way we used to solve this problem was periodically refresh the contents of the publication once every 15 minutes. And this way we would know if any changes were made. However, there is a drawback to this approach. Any DMLs performed between these 15 minutes, that is actual performing of the publication change and the periodic refresh, such DMLs could be missed. So to fix this is a new solution. Any change in publication's content will bring about a change in some of the catalog tables. So to detect such a change, we will detect the change event in the catalog tables, just like how we detect change events in the regular tables. We already maintain a consistent ordering among the list in the publication. We will also use this catalog tables change event records and put them in the consistent ordering. So as soon as an appropriate catalog table change is detected, we can refresh the publication's contents. This way, we won't miss any records and the consistency will be maintained, hence achieving Postgres parity. Now, let us look at a quick demo as to what I mean by all this. So for this demo, I've used a single node YugabyteDB instance, and let's just get started. Let's log in into the YSQL shell and create some tables. I'm creating 3 tables here, and all the tables have the same simple schema, single column integer primary key, and the names of table are test table 1, 2, and 3. Now let's also create a publication. I've created a publication pub, which includes table 1 and table 2. Note that the third table is not part of this publication. Let's also create another publication, which includes all the tables. So this publication pub all tables now contains all the tables in the database, that is the table 1, 2, and 3. We can verify that publication creation has gone according to our needs by running a query on pg publication tables. And here you can see pub has 2 entries corresponding to table 1 and 2. Pub all tables has 3 entries corresponding to the 3 tables. Now let us start consuming these changes. I will deploy 2 Debezium connectors. The first one will use publication 1, that is pub1 pub, and the second one will use the all tables publication. So this is the first connector. I'm using the publication pub, replication slot 1, and all the changes that will be shipped by this client will be sent to Kafka under the topic prefix db server 1. Now let us start another connector, and this connector will use the publication all tables. We will use a separate slot, YB replication slot 2, and the prefix for the topics for this connector will be db server 2. Each of this connector will create a slot automatically. So we can query the PG replication slot once to verify that the connector has started and it has created the slots. So as you can see here, the 2 slots are created, and you can check the active field is true, which means both the slots are being actively polled. Now let us perform a transaction and insert one record in each of these three tables. As you can see, I've inserted primary key 1 in all the three tables. Now, since the first connector is polling on table 1 and 2, we should see those records being published in Kafka. To do that, I just go inside the Kafka Docker container and print the topic contents. So I'm printing the topic contents for DB server 1, which means they have come from the first connector, and for table 1. So as you can see, we have one record which is corresponding to test table 1, and in the payload field, you can see that we have received the primary key 1 in this particular message. Similarly, let us check for table 2. Here, I'm printing the records of table 2 in the topic. This is also for DB server 1 since it is sent by the first connector, and the payload is 1 for test table 2. What do you think will happen if I try the same thing for test table 3? So here, when I do this, I get an error saying that this table is not available, which is correct since the publication which is being used by the first connector does not include table 3. But if you remember, we also had another publication which was polling on all the tables. That particular publication was used by the second connector, and if we look at the DB server 2's Kafka topics, we should be able to see the records corresponding to table 3. So let us print them here. And yep, as you can see here, when I try to print the topic for DB server 2, for the table 3, I get a single record corresponding to the primary key 1. Now let's see what happens when I create a new table. So let us create a fourth table, test table 4, with the same schema, single column primary key. And yep, we have created the table. Let's look at the PG publication tables. Yep, as you can see here, the pub publication does not include the test table 4, but the all table publication contains test table 4. So now let us insert a couple of records and see if they are if they are being correctly replicated by the second connector. So I've inserted primary key 1. Let's also insert primary key 2. Yep, the inserts have gone through. Now let us publish the contents of test table 4 Kafka topic, which were populated by the second connector, that is DB server 2. Yep, here you can see for the test table 4 and DB server 2, we have received two records for test table 4. The first record has primary key 1 and the second record has primary key 2. Now, let us also add this newly created table to the first publication that we created. To do this, we have to run an alter publication and add the test table 4 to publication pub. This is how we do it. Now, let's again query PG publication tables. And here we see that the publication pub now includes test table 4 as well. Let us now perform another insert. I'm inserting the primary key 3 now, and this insert has gone through. Let us publish the contents of Kafka topic for test table 4 for DB server 1, that is the connector which is using the specific table publication. As you can see, I'm publishing the DB server 1's content for test table 4. And in the primary key, in the payload, you see that we have received the primary key 3. Now, you may wonder, why did we not get primary key 1 and 2? And since we have specified from beginning here, that is, we are getting all the change events in this topic. This is because, if you remember, the primary keys 1 and 2 were inserted before performing the alter publication. Hence, it is correct behavior to not stream those as they were committed before performing the alter publication.
So from beginning semantics, we are just matching Postgres' behavior, that it only, even though we say from beginning,
Right.
it's only after the table was added to the publication.
Exactly. This from beginning over here is basically printing everything in the Kafka topic.
Yeah.
So we are following the Postgres semantics of streaming in the consistent order.
Yeah.
And we are not streaming anything which was done, which was inserted before alter publication. And yep, with that, I come to the end of my presentation and my talk. Feel free to ask any questions if you have.
One more question, which is when you initially showed the metrics in the Yugabyte Anywhere panel,
Yep.
is there a plan to add, publication specific or slot specific replication lag metrics?
The metrics which I have shown you, Kannan, are already replication slot specific. The reason I'm getting a single dashboard is because I only had a single replication slot on my universe.
Got
So
it.
if you see here, this basically lists down all the replication slots, and I only have 1 year. So if I had multiple slots, I would get multiple rows, and clicking on each of them would give me 4 such panels for each one of them.
Perfect. Got it. I missed that.
Yeah.
Wonderful. Thank you, Sumukh, for a really nice talk. Just good to see a lot of these very fundamental enhancements to improving observability and semantics of our change data capture to make it pretty much on par with the Postgres logical replication. I know there's a lot of performance and throughput improvements also coming in this general area. And thanks everyone for joining us on another Friday Tech Talk episode. And see you all again next time. And over to Sumukh for closing remarks as well.
Yep. Thanks, Kannan, for this opportunity. And to our viewers, if you have any questions, you can just join us on Slack. And yeah, don't forget to reach out to us. Yeah. Thank you. Thank you very much.
Thank you.